So today we're going to do truth and trust. So this is the fake news lecture. Yay! It's funny. I had a few slides on this stuff a couple years ago, and then the 2016 election happened, and my God, everybody wants to talk about this all the time. Money is pouring from the sky to do this stuff. This is a huge subject, and it's a very interesting subject. It's a very interdisciplinary subject. There are many ways to approach this subject. I'm going to take one particular approach, and I'm sure we'll have a lively discussion about it. So this is the way that I'm going to go with this. I'm going to sort of take a tour of the institutional and algorithmic side of this stuff. I've also written papers on institutional responses, sort of more from almost from a counterintelligence point of view. But we're going to try to zero in on some of the computational techniques because this is really the place to talk about that stuff. The first thing we're going to have to address is what is it that we're talking about when we're talking about fake news, false news, disinformation, misinformation. What other names are there? Weaponized narrative, that's what the military people call it. There's another 5 or 6 names for this idea. And it is, of course, a highly politicized topic as well. And it gets to really foundational issues of censorship and freedom of speech and truth and political bias. And so the first thing we're going to look at is a framework for assessing the quality of a piece of information. In our case, most likely a news story. So here's the problem setup. We're going to look at the work of the Credibility Coalition, which is now a W3C group. And they are interested in open standards for credibility annotation. So here's the idea. We're going to need various types of machine help to deal with, I'm just going to use the term false news as opposed to fake news. This has become common among researchers. We're going to get a little bit deeper later into what exactly this word means. But think of it as stuff which is objectively untrue, right? I'm not talking borderline stuff. I'm not talking exaggeration. I'm not talking unbalanced reporting. I'm talking just made up stuff, right? Just stuff that isn't true. And the idea here is we want machine assistance of various sorts. So maybe the obvious thing to do is to penalize the distribution of this type of information in our filtering algorithms, which, if you're doing it at scale, means identifying it at scale. A less obvious thing to do is, rather than penalize the distribution of it, to show the user that something is wrong when they view that story, right? So you've probably seen things to this effect on various platforms. This story is disputed, or here are some more articles, or fact check, labels, and so forth. To do that, we need structured representations of the veracity of articles and claims. So here's the idea. The Credibility Coalition is trying to set up frameworks, as they say, for this type of process. We start with some story. Somebody looks at it. There's some combination of human and machine review that generates basically a training data set of here's what good and bad information looks like. And then that can then be fed to automated systems that can try to learn what's good and bad information. Okay, so the idea is you have some human process that you then boost to try to produce an automated process. And this is happening now. So the major platforms are in fact doing this in various ways. So the first step of this is trying to come up with a uniform way of assessing a story's credibility, right? Some standard for fact-checking, basically. So how do we do this? I give you a random story, right? I just throw a random URL at you. What are the signals we can use to decide on the credibility of that story? Let's make a list. It's your time to shine.
What's that? Wait, sorry, I was blanking out. No, I'm actually on time. So that's just for credibility of a story?
Yeah, so I give you a URL and you have to evaluate things. You have to evaluate this URL. So what do you look at? How do you figure out whether you should believe the story?
Well, the author, tend to look at the author to
Okay.
see if they actually are someone who has some credibility. That tends to be like the first thing I look at.
Okay. So you right.
If it's someone I can trust, someone who's able to like go in and like go the extra mile to like verify the accuracy.
Are you on like a first name basis with Paul?
No, they're like if I see like a really egregious story, I'll like see who wrote it and then
Probably look at the publication.
Yeah, you can start publication.
oh yeah, publication as well. Yeah, exactly.
Okay, so that doesn't really solve the problem, right? Like, how do you decide how do you assess the credibility of a publication?
Editorial board, look at who's on it, what their reputation.
Okay, and then how do you assess the reputation of somebody?
Do we have a corpus?
Yeah, exactly.
So I think
Would
the
you
way
like
that
purpose?
we assess the reputation as journalists is very different from the way that a general audience person assesses.
Yeah.
Because we probably do if we're consuming lots of news in a very intentional way every day, we may well have like a list of publications and a list of specific journalists that in our minds are ranked somehow in terms of credibility. But like how does a person who doesn't have that internalized list assess these things?
Yeah, so what I'm hearing a lot is something about a set of lists. And it's a problematic notion, but it's a very realistic notion, and everybody eventually ends up with a list, one way or another. But it's hard to argue about what should be on that list, and of course, whenever you have conflict or polarization, people on opposite sides of that will have different ideas about what that list is.
But we're talking about false news. We're not talking about exaggerated or like rhetoric. Or we're talking about like they said the person was arrested. The person was not arrested. There was no arrest.
Yeah, but it could be an interesting signal, right? So, in fact, it is an interesting signal. We'll see soon that the tone of the article, although in principle the tone has nothing to do with the truth or falsity of the article, in practice it's very strongly correlated.
Okay, has anyone seen the New York Times series on YouTube about disinformation campaigns that was just released? I forget exactly what it's called. It traces the roots of how it started in the Soviet Union in like the 80s. How they put out the story in India about the US government spreading the AIDS virus.
Africa, but yeah.
Well, it started in India, and then that news article spread through Africa. And that's how this whole domain of disinformation campaigns started.
That Russia invented the domain of disinformation campaigns.
On large scale, yeah.
Yeah, I mean, it's ancient.
I know it's ancient, but think global.
They invented propaganda.
Well, those two things are different, right? But what this series is talking about is how, in modern times, how it's able to spread globally. on this large a scale, and how the meddling stuff today is rooted back into that. It's a really interesting series.
Yeah.
Yeah.
So what other indicators? So we look at the article. How do we decide what to think about it?
I mean, if the claim just seems like outlandish, I'm like not gonna. I'm gonna use more. If it's really out there, you know.
Outlandish claim. Yeah. Okay. What else?
Check for,
This is showing how difficult it is.
check for is there any like reference mentioned in the article? Like if someone saying there's a research backs for the research that really exist.
Yep. Citations.
Citations.
Yep. Good work. What else?
About
So-
what's it?
I guess it's just cross-reference if something they mentioned also appeared in like other part of the internet or from other sources.
Okay. So
Have other people written about the same project? Or?
credibility of sources. Cross. Cross-check the content. Okay. What else? There's lots and lots of these.
I'm on the fence about this, but check what people are tweeting about and like what the reaction to the article is. Or-
Sure. Yeah. I mean, yeah. It's could be an important signal if a bunch of people are saying, "Hey, that's not true."
How about funding for the publication, where the money comes from?
Funding. Yep, that's a good one.
Motivation for this article.
Yeah.
How far away the publication is from what they're writing about, so.
How far away the publication is. Like, do they normally write about this thing?
What?
As in, does this publication normally write?
Oh, no, that's not what I meant, like geographically, like if they're writing
Oh, okay.
about something, that.
Oh, literally how far away they are.
Literally how far away?
I think, no, I mean, I know it sounds silly, but maybe it's something we should think about as media does become more consolidated and
Yeah.
like they're parachuting journalists into places,
Yeah.
where they're not based, yeah.
But I guess we could also include, do they write about this often or is this just
Yeah.
like almost sponsored content?
What about if you look at a page and it's full of ads for diet pills? Does that change your opinion of the credibility of the article?
It means their funding is not going super well.
That's kind of a tough one. Yeah, I agree that the funding's not doing very well.
Yeah,
What's
so
the
maybe
article?
there's
What's
also-
the article about? I mean, if I'm
Yeah,
reading
what's
about
the
sports
flavor?
scores, then I don't think the diet pill industry has that much influence.
What I'm trying to get at is, think about what else is on the page here. Do you care about that?
Sometimes places do have questionable ads, but it's,
But do they always have control? Especially in the early days of Google AdWords or ads, right? Did they really
Yeah.
have control what was displayed
Well,
on the page?
you could not use Google Ads. Right?
Yeah. Sure, yeah, that's true.
Outbrain a lot. Does anyone know what outbrain is?
Yeah, Outbrain and there's a bunch of these. They're like the related content engines, right? It's that stuff is called chump. It's all of the weird links at the bottom of the page.
Yeah.
Yeah.
Chum?
Wait,
Yeah.
what's chum? The links.
Well, chum literally is.
Thank you. Well, what are these links in the bottom of the page?
Oh, well, just I don't even know if I'll have it because I've got an ad block on. But it's just like at the bottom page it says related stories and it's got like weird celebrity news. And
Oh,
your doctor doesn't want you to know. Yeah, that stuff's called chum.
And I always click on that stuff too.
Yeah.
Number 7 will surprise you. Every time it surprises me.
All right.
I read fake news.
All right. So I'm gonna put
Very
ads on page because that actually does turn out to be an interesting signal.
Can we go deeper into that though, if you don't mind?
What?
Like, what do you mean about ads on page? Like, just the content of the ads, if it's iffy, if it's suspicious?
Yeah, if they're
Almost
crappy
all
ads.
have ads. So, but like, how do you define? We're being very specific, right? And how we define fake news. So, how do you define a crappy ad?
I mean, okay, good question. But I think you all have a sense of like which advertising is more or less spammy.
That's
Like
what
if it's
I would have
snake
thought
oil.
before 2016 and news articles.
Yeah.
But you know what I mean? It's very
How,
arbitrary.
how many people go to a publication's website and then like look at their homepage and then like choose an article to read? Versus like read a specific article that was
Or even read an article. A lot of people just read headlines. And you can't even
Right.
see the
I
content.
guess I was thinking of like this community, like in this room,
Oh,
like
okay.
I can't remember the last time I went to like I don't know a news source and just like scrolled and just like clicked an article rather than like following a specific journalist or looking at a specific article that was tweeted. And so then like the ads on a page doesn't really intervene in that because I'm not assessing like the aesthetics of the website that is publishing the.
Yeah, okay, but when you're looking at the article page, I'm suggesting that the quality of the advertising on the page is an interesting signal for a variety of reasons. What about the headline? Can we learn anything just by reading the headline that might be relevant to the veracity of the article?
You want what the headline says to match the content of the article, I guess.
Yeah. So
Don't just read the headline.
well, that's good advice.
Just people buy it.
So if the headline contradicts. And some headlines are clickbaity, right? So the number 7 will surprise you headline, you won't believe, your doctor doesn't want you to know, right? So, clickbait headline.
Maybe the domain name,
What's that?
the domain.
The domain name, yeah. This one turns out to be an important signal.
Oh, what do they have?
What do you mean? Like some sort of hash in the domain name that makes it look like.
Oh, even if they
No,
have
just-
HTTPS or something. right?
So, what's that?
Whether they have HTTPS?
Right, so that's an interesting signal. Let's say how old the domain is when it was registered, for example. Which country it's in. I guess maybe that would go back to geography. But the domain turns out to be an extremely important signal because people make domains to produce false news. And the other reason the domain is a very interesting signal is because it's a lot more efficient to fight false news at the domain level than the story level. Right? If you can say everything from this domain is junk.
I can't share S3 links on Facebook Messenger.
Oh yeah?
That was really interesting. Yeah,
Huh.
like just raw S3 links, you can't share it on Messenger.
Interesting.
That was fascinating.
Yeah, too many people have used it, I guess. Okay, so there's this whole list of things. This is how the credibility coalition operates. The idea is that you start with stories. As a ground truth, you rank them with domain experts. So if they're health stories, you have doctors review them. And then the research community, so today that's us, makes these guidelines which try to tell people, how do I, things like this, right? How do I look at a story and decide if it's true? And so here we're talking about independent of going and doing actual fact-checking research, right? So we're trying to look for signals that you can assess quickly without doing further investigation. And then they get journalism students and people like that to try to mark up stories according to these indicators. And what they do is they compare the annotations of these indicators to the credibility as scored by the domain experts. And the goal is to try to find sets of indicators that correlate strongly with the ground truth provided by the experts. And then the idea is that that produces a training data set which ultimately goes to, it says here, AI developer and app developer, right? So the project here is to develop and test a set of indicators which have strong correlations to domain, so a couple goals here, right? One is you want indicators that correlate with what domain experts say. And you also want indicators that are easy for relatively untrained people, non-domain experts, journalism students, this sort of thing, to apply. Yeah.
So here saying that we are sort of depending or trusting the judgment of people in journalism.
No. Ultimately, the ground truth is from the domain experts. We're trying to find indicators that can be assessed without domain expertise.
And domain experts would be?
People who have domain knowledge of the subject of the article. So if it's a health article, you get doctors with knowledge of that topic. If it's about the economics of India, you get people, you get economists in India, this type of idea.
Not like beat reporters.
Not beat reporters, yeah. All right, you're trying to find things that, so journalists don't really have expertise, right? It's kind of a funny thing to say, but that's actually not our job, right? If what you want is deep expertise in something, like journalism probably isn't quite the place for you.
I don't think that's true of like political reporters who report on a beat in a specific community for much of their career.
Mm-hmm.
I think that they are very specific domain experts
Mm-hmm.
in communities and networks. Like it's just a domain. It's just an expertise that can't really be written down. And
Mm-hmm.
I guess the test would be, could they do the job if they wanted to? The actual job that they're reporting on, if they wanted to. That would be a good test.
no, like the test is if they're a good reporter or not. Like
No, I
their job
understand
isn't to be a
that,
politician,
But
but
surface level versus depth knowledge is
yeah,
something.
but like as someone who's reported on like I don't know like Albany for the last 20 years and like
But is an expert on what Albany?
Yeah,
on state government in New York.
I mean, clearly journalists develop deep expertise in some sense, but a science journalist is not a scientist, right? There's a difference.
But it just seems really, I don't know, it seems very strange to argue that like I guess we don't really have local reporters in the same way anymore as we used to, but it seems strange to argue that they shouldn't be somehow involved in this process of assessing veracity, because that for like as I don't know, recent history, like since journalism was decades has been the expectation that.
Well, let me put it this way. If you have a story about, the Vatican says this or that, it's the difference between asking somebody at the Vatican and asking a journalist who covers the Vatican.
Right. That's scary though, because one is accountable to the community and the other one is accountable to the Vatican.
Right, but the journalist can't speak for the Vatican, right? If it's a claim about the Vatican saying, because this was a real piece of fake news, right?
Yeah,
The Vatican
yeah.
Endorsed Trump or something, right?
Right.
And the Vatican would be the ultimate authority on whether the Vatican endorses Trump.
Sure, but that's a situation where it was in their interest to refute that. If it were a private company or
Mm-hmm.
or a government where it was not in their interest to refute whatever claim,
Mm-hmm.
you can't. I guess this is sort of introducing the idea that we can trust entities that are not accountable to communities to police themselves by deciding what is truthful and what is not.
Journalists are not experts. That's going to be really important when you cover complicated things. Like there are people who spend their whole lives in a thing, and they are journalists who like do a story on this thing and then do a story on this thing and do a story on this thing. Like they just don't know as much. And this becomes, the more complicated the subject is, the more important this becomes. And it's very easy to make bad mistakes. I see what you're saying, but let's move on because we got a lot to cover. So this is what the credibility, so this is one of the first piece of research out of the Credibility Coalition. In this case, I think they had a climate change story and they had a health story, and they sent it to a bunch of experts to review the credibility of the articles, and then they developed two types of indicators. Content, so this is an analysis of the article itself, and context, which is stuff around the article. So for example, they ask people to look for a number of logical fallacies. And those are things that happen in the article versus, how many ads are on the page or what is the reputation of the sources. And for each of these, they computed inter-rater reliability. This is a thing called Cronbach's alpha, which is, it's 1 if all the raters agree and 0 if they don't, basically. So first of all, can people reliably agree on, whether this indicator is present? And then they look at the correlation with the expert ratings. And the idea here is to try to find indicators that strongly correlate with what the experts believe. So the expert ratings are taken as ground truth, right? So regardless of the issues there that you bring up, the sort of notion is, can we duplicate expert reviews cheaply? And a few of them you can, right? So it seems very easy for people to tell if there's a clickbait title and you have a strong negative correlation with the expert's credibility assessment. Or tone is this very interesting one. From a logical point of view, there's no reason the tone should correlate with the truth of the information, but it turns out it does pretty strongly. Right? So our intuition that somebody who is, has a very strong partisan motivation or, is very angry or very enthusiastic about something, that maybe that reduces the reliability of the information, seems to be true, at least in this sample. On the context side, so it turns out you can produce better predictors if you take linear regressions of these. So they've built these models. Where is it? Right, so here's ultimately what they're trying to go, is they're trying to use these cheap indicators, which you can have untrained people assess, or maybe automated methods, and see if they can end up with good scores that correlate strongly to expert assessments. So the best they could do was building a model for the internal indicators. What do they call it? Content indicators, clickbait title, and logical fallacies. For the context indicators, they had to combine a number of these other things and got a pretty good predictor of credibility. So that's the idea, is that maybe rather than just starting from a labeled data set, these are true claims, these are false claims, these are true articles, these are false articles, and trying to run a classifier on that, maybe we should get a little more granular. Everybody at this point has taken a data set of true and false articles and tried to build a classifier on it. And it's not a very interesting thing to do. I've had, there's 5 or 6 students at this school who have done it. I get questions about this nearly on a daily basis. It's sort of the technologist's first answer to this problem, and it doesn't work particularly well. Let's talk about why. Why is running a classifier on just a document classifier? We've talked about document classifiers, right? You can use bag of words and use that as features and throw your favorite machine learning model on it. Why doesn't that work?
There could always be an exception after whatever you have as your limited true set or false set, it's more ambiguous than what your data could show.
Mm-hmm. Yeah, what else?
For fake news producer, is that possible? Like, if they know what's the algorithm's like criteria, like, is that possible? Like, they just reverse engineer and like somehow play with the system and try to get a higher, like, more trustworthiness score?
Yeah, so there will always be people trying to game the system. I mean, even with search results, like forever. But it's just not going to work very well building like simple classifiers. So I say that without justification. I'm wondering if you can supply the justification for why that's not a great plan.
Like Bag of Words, I feel like doesn't have enough to really tell what's going on. Like whether or not something is true can really come down to the position of one word in a sentence. Could completely change the meaning.
Semantic relationship.
Yeah, so right, so exactly. That's one of the big problems of Bag of Word, right? So I can put the word "not" in the sentence and completely change the polarity of the claim, and Bag of Words will not pick that up. So that's one problem, is that there's just not enough semantics to really do this well. Another problem is that when you train classifiers on sets of true and false articles, what the classifiers normally pick up is source and content, right? So what happens is the classifier learns that anything with the word Clinton and WikiLeaks in it is going to be false, right? Or anything that comes from a particular source, so anything that says Denver Guardian, which is, here I'll use the term fake news because it is literally a fake news website. There is no Denver Guardian. There's only one article on the Denver Guardian website. It's probably down now, right? So it learns that anything that comes from that source is junk. Basically, the problem is that simple classification on training sets of real and fake articles doesn't generalize, okay? I think it's fairly obvious that if you train that on 2016 election data, US election data, it's not going to work in other countries. It's maybe less obvious that it won't even work in this country on the 2018 election because the topics are going to be different. It might work a little bit if it's picked up source information and there's consistency and source credibility. But really what they're going here is they're trying to look at more sophisticated features, and they found some. So this is the state of the art. This is where we are now. This is a W3C community group. You can learn more about it by going to the Credibility Coalition org. This is one of a number of groups who are working on these types of problems. This one is has a fairly wide set of partnerships between tech, journalism, and academia. And interestingly, is now a W3C working group, right? So there's some standards track stuff going on. Yeah, okay, I'm not finding the place on this side where they talk about it, but this is, the ultimate goal is to develop web standards. And we're starting to get standards for representing the result of checking the claims in an article. So you all remember schema.org? Yeah?
Yes.
Okay. So this is the claim review schema from schema.org. And this is in wide use. And basically, most of the fact-checking organizations, when they do some sort of analysis of an article or a claim, they publish a claim review object, right? So this would normally be on the page which has the fact check. And this is a structured, machine-readable way of saying, what was the result of the fact check. So let's see if we can find one of these. Let's go to, what's your favorite fact check organization? Pick one. Snopes. Okay. Did the Obama, okay, so here's a fact check. Mostly true. Oh, look at that. I had no idea. And let's view the source. And let's search for, whoa, schema.org. There we go. There it is. Schema.org, type claim review. Oh, weird. It's in a JSON blob. Anyway, I'm not sure exactly how this markup is supposed to be working. But anyway, there we go. It's using the schema.org claim review schema to produce a machine-readable claim. All right, who uses this? Who reads this data? Yeah. Right, so this now, so we're sort of walking through the pipeline, right? So I've started with, how do we assess the credibility of articles at all? And then when we've done that, now of course Snopes is doing this with expert manual labor. The idea is that we're trying to develop indicators that will allow smarter automated or semi-automated systems. In either case, the result is some metadata making a truth statement about a claim. And now we get into what are the platforms doing about false news. And one of the most obvious things they're doing is they're reading these machine-readable claims, and they're presenting them in the UI. And so this is what this looks like on Google. The idea here is you search for something, and if it finds a relevant claim, it puts it as a banner there. You can also get a carousel of fact checks if you end up searching for a particular fact check site. Facebook also does this. Has anyone seen this on Facebook? So this is what the modern system looks like. Facebook used to have a thing that says this article is disputed. That was their first pass at this. This is a very interesting article. What's that?
No, I love that the first button is post anyway. Each check flags, option number 2 or number 3.
This is a very interesting post. This is from the Facebook design team, and it talks about how they redesigned their fact check banner. So here was the original one. And it used to say, disputed by Snopes and PolitiFact. And when you tried to post, you got that. And they changed it to this. And this post details their reasoning about this, right? So now we're trying to close the loop, right? We've gone all the way from identifying false information to marking it up to ingesting it by the platforms. And now we're talking about, okay, what do we show the user, right? We're trying to complete this intervention to reduce the spread of false claims or the effect of false claims. And they said that what they didn't like about the disputed flags was a bunch of stuff. They're saying, I guess it takes too many clicks. They're talking about the backfire effect. This one I think is less of a strong case. The backfire effect is the idea that telling somebody that something is wrong could make them believe it more. There was some early research suggesting this is the case, but there was a team that just tried this in 50 different cases and wasn't really able to replicate the effect. So I'm not sure if this is a real psychological effect or not.
Could be more so now, given the recent PR of Facebook, just how they're viewed in the media lately, given all the data breaches. They don't have a very high trustworthy score at the moment.
It's not just fact checkers, it's just telling somebody that something is a false idea. Right, so that's actually kind of the good news in this, is that so we're not going to get too much into this today, but when we're talking about interventions, we have to talk about the psychology of belief. And you have to ask questions like, if you tell somebody that something is wrong, do they change their belief? Do fact checks actually work? And the answer seems to be, yeah, actually telling people that something is wrong makes them believe it less. Not necessarily a big effect. It often has to be repeated many times. It's not a certain effect. People often won't change their minds when you try to tell them something is false, but it does work on average. This was one of the main problems that they were having, is that it just, when they initially put that disputed flag, they only put it up if at least 2 fact checkers had checked the same thing and agreed that it was false. And so it was just taking too long for things to be rated as false, right? It just took, maybe it took several days or maybe it took a week for 2 fact-checking organizations to get to it. By that time, it's mostly spread as far as it's going to spread. This is part of the challenge here, is you need real-time response. And the other thing they're saying is there was no way to handle ratings other than false, for example, true. So they've changed their design to just make it basically just say related articles. And one of the nice things about this is that because they're not making a claim that the thing is true or false, they're just saying, hey, someone else said something about this. They feel comfortable doing that when there's only one fact-checking organization.
It'd be interesting if users were notified when articles they had read were then later fact-checked to be false. Like that could be a solution to that problem.
Yeah, so this is something that only the platforms can do. And in fact, Facebook has since sent out notifications to hundreds of millions of people that they saw it. Did anyone see this? Yeah, so...
What about the ones that were placed by their campaign, the one that came out in the New York Times about 2 weeks ago?
Sorry, which?
It was covered in the New York Times.
Yeah, I remember the big article.
Campaign. They hired right-wing consultant firms to link activists to George Soros and other things.
Yeah, right.
Discredit claims against Facebook.
No, so that stuff didn't appear on Facebook. That was external PR, so that would be,
Oh.
yeah.
But it was also shared on Facebook platforms.
Yeah, I don't know if they're going to do anything about that. I mean, this took like over a year. I'm trying to find a picture of this, but they actually did send notifications, and I remember getting one of these.
So if you made an impression on a fake news post, meaning that you viewed it or was in your news feed,
Yeah.
on the screen at some point.
They actually, yeah, exactly. So there's now this tool you can see if you've interacted with just a very particular set of, I can't find a picture of it right now. I'll stop looking. Just a very particular set of posts from the IRA. So the platforms actually have the option of notifying you that you've seen something, which is something that other actors in the media ecosystem can't do, right? Journalists can't do that. So there is a collaboration between Facebook and fact checkers, as we've seen here. There is a nice CJR article on it, which is linked off the syllabus, which is a report that came out of the Tau Center earlier this year, talking about how well this works. And basically how this works is that there is an internal portal, a dashboard, there we go, which Facebook maintains, and nobody really knows how they identify the stories that need checking. But if you work at Snopes or PolitiFact or FactCheck.org or a bunch of other news organizations who are involved in this partnership, it has a list of things that need checking, and you can pick one of these stories and check it and report back to Facebook what your rating is. And then that ultimately drives the related fact checks feature in Facebook.
Sorry, say it again. So the users that flag content? Users flag content?
Well, so we know that users do flag content.
Yeah.
We don't know exactly how things, here we go. This is people complaining about not knowing how things appear on this dashboard. So this is a private dashboard. You or I can't see this. Only people working at this fact-checking organizations can see it. And it contains stories that Facebook thinks should be checked. And it's some combination of users flagging it and algorithmic determination. And we don't really know. That's part of what these journalists are complaining about. We don't really know how these stories are chosen. And then these fact-check organizations pick things from the dashboard and assign them ratings.
One thing I found that was interesting was every user has a trustworthiness score as well. I don't know how true that is. When we were doing our filter design homework assignment, I read up on that.
Uh-huh.
And apparently, if someone's flagging a bunch of stories that are determined to actually be true,
Mm-hmm.
it brings down the individual's trustworthiness score.
Right.
And that trustworthiness score probably applies here as well. The types of people that are flagging the content.
Yeah.
I'm wondering. But I thought that was interesting.
So we know that Facebook not only has individual trustworthiness scores, but it has news outlet trustworthiness scores. Do you remember when they did the Trustworthiness Survey? Did you ever see this? Okay. So this was January this year. And what they did is they sent out this survey, which, they don't actually have a picture of it here. It was one question. I'm trying to find this. Let me see if I have it in my bookmarks. Oh man. There you go. So they sent out this survey to many of their users. I got this at some point. And interestingly, it was domain-based. This was part of an internal shift. So what happened is they ran the collaboration with fact checkers for a year. And one of the things that came out of that is it simply didn't scale. Checking individual stories was never going to handle the volume of false information on the site. And so they said, okay, we have to do better. Let's start filtering by domains and not just URLs. And so to do that, they need quality signals on domains. And so they generated an initial data set by just asking these questions. And basically this is it, right? Have you ever seen it before, and how much do you trust it? And so we know that's one of the signals Facebook uses. And that may explain why one of the fact checkers was saying, you know, they never see InfoWars on the list. Maybe the reason they never see stories from InfoWars to check is because Facebook is already filtering out contents from domains that are ranked very low. So there's some very complicated system that Facebook is using. We don't really know how it works. We get little indicators, little pieces of the puzzle. We know there's an article level part of it. We know there's a user level part of it. We know there's a domain level part of it. We don't really know anything about the effectiveness though, right? We don't really know anything about, you know, has this reduced this spread of false information? How much false information is there? How is this working out? It's all very black box. And so there's a lot of reporting to be done on this stuff and a lot of people doing the reporting. So this is one aspect of platform response, is the sort of, think of this as the sort of operations level, or think of it as integrated into the filtering system. There's another type of response, which is more of a security style response. And actually it originally started in the security department in Facebook's case. And this is countermeasures against targeted persuasion campaigns. So first of all, let's actually look at this paper here. This is an incredible document. This came out last year. And if you really want to understand this problem of false information, you need to read this document. This is the most comprehensive statement by a platform on what's going on. First of all, they're defining the problem they're working on here. They're using the phrase information operations. And they're defining it as coordinated campaigns that are explicitly about political persuasion. Okay? So they're looking for a strategic or geopolitical outcome. In other words, not money. They're not doing this to make a buck. They're doing this for political reasons. And as it points out, this is a very old idea, right? This is literally ancient. But they also point out where do they say this? Yeah, I don't think they say this in this document. They say this in another post on their Facebook blog. They say that most false information on Facebook is financially motivated, okay? So while most of the attention has gone to information operations like the IRA or equivalents in many countries around the world, because this does happen globally, most false information is literally nothing more than clickbait. Right? The only point is to get you to go to a site to view ads, or another very common thing is affiliate links. You all know what affiliate links are? So an affiliate link is, if I go to a mattress review site and it says, Casper is a great mattress, and then I click on the link and buy a Casper mattress, they get a commission. And in fact, by the way, this is a whole other crazy story. There's some very good reporting on how Casper has bought off, threatened, and bullied the mattress reviewing blogosphere to ensure that their mattresses are always top ranked and most recommended.
Big mattress.
It is big mattress. So there's some remarkable reporting on this, by the way.
Yeah, they have great reviews everywhere.
That's why.
And I didn't find them all that different than the other.
Do you have a Casper?
No, I tried it though. It's okay.
I mean, I'm sure it's an okay mattress. So here's some of the reporting on this. There's really good reporting on the tactics they use to ensure that all of the sites which review mattresses rate them highest and put their affiliate links highest, including suing bloggers.
Oh, wow.
Yeah, it's really something. But anyway, affiliate links are big money, and if you can get people to go to your site and then buy a product, you can make a bunch of money. And one of the easiest ways to get people to go to your site is to tell them something with a strong emotional charge. And why be constrained by the truth? If what you need is a strong emotional reaction, it's much easier to do that if you don't have to worry about whether it's true. So most false information is financially motivated. I've never found a source for the exact proportions. I would guess it's like 80% at least, okay? So when we were talking about information operations, which is this stuff, this is a small fraction of the false information that is on the internet and on the platforms. Obviously, it's a very significant fraction because it can have large real-world consequences. So this paper is Facebook's response to it. And so they've got this sort of picture of how it happens, right? Is that somebody creates false information, possibly by using stolen material, right? So the security team is concerned about phishing and getting into private accounts and so forth. Then somebody has to make something, they have to write the article or make the meme. And then you can also amplify it. So everybody's been talking about bot networks, right? This is where that comes in. So there's different phases of the operation. Crucially, Facebook says here and in a bunch of other places that they decide whether something is allowed on Facebook, not so much by the content, because obviously you can have political speech on Facebook, but they say the inauthenticity of the account and its behaviors. So in terms of political content being shared on Facebook, they claim that they're not concerned about what you are sharing. They are concerned about whether you are who you say you are. So for example, bot accounts are an obvious one. They also discovered things like people creating pages that looked like activist accounts run out of by American organizations that were actually run by Russian organizations, right? So it's hiding who you are, what they call inauthenticity. And then here's this bot thing. There's been a lot of focus on bot and bot detection, but as we shall see, bots are not actually necessary to get big information cascades of false information. The other thing that's interesting is, has anybody looked into what everyone knows what I mean by the IRA, yeah? Okay, the Russian troll farm, the Internet Research Agency. What types of messages did they promote during the election, the 2016 election? Anybody looked at this?
A lot of Hillary email.
Yeah.
Mm-hmm.
Hillary email stuff, WikiLeaks stuff.
Topics that were generally polarizing.
Yeah, so they created a bunch of groups that looked like legitimate activist groups, and often got a lot of legitimate activists involved. So there was a big one called Blacktivist, for example. They were involved in many of the Black Lives Matter group. There was a lot of immigration stuff, and they would generally play both sides of this issue, right? So they did a lot of activity online, which was essentially indistinguishable from normal the normal activities of social movements. They would push both sides. They actually got people out to rallies in many cases. It was really effective. You know, and they have an advantage because the things they say don't have to be true, right? Okay, so the ultimate answer to handling false news at scale is to try to get automated pipelines that can tell. This is a complex topic because there isn't really a way to tell if something is true or false without external checks, right? This is what a fact checker does. But as we've seen, there are a lot of signals which can be used to make often quite accurate determinations. And we also have huge databases now of fact checker output. So one of the things that people would like to build is an automated real-time fact-checking system. The idea is that you could watch a political speech and it would run text-to-speech, find claims that contain factual content, match them against previous fact checks, and display in real time or actually near real time whether what they're saying is true. And actually, I think it was yesterday that there was an article in Nieman Lab publishing the results of a study on how people, sort of the user end of this, how people respond to this. So this is the idea. You'd be watching a speech and it would pop up a banner talking about fact check related to something they just said. So yeah, this was, yesterday. By Bill Adair, who's a name you should know, who runs PolitiFact. And so he's involved in this collaboration with a bunch of researchers to try to actually build this system. There have been prototypes around this. The Washington Post did something called Truth Teller. There was a thing called Truth Goggles a few years ago, just little experiments. The Tech and Check Cooperative is another collaboration around truth and fact checking, and they're focused on this idea. And apparently this article is saying that generally they liked it. There you go. Participants were unanimous that they would like a feature like this. All right, so focus group says it's popular. How do we build it? The first piece of research I want to show you is a thing called Claimbuster. And this is this middle box, the Checkworthiness Filter. The idea is that this is a filter on whether any particular claim is actually worth checking. In particular, Claimbuster is, what it ultimately is it is a three-way sentence classifier. And what you're looking at here is the training data generation interface, right? So they crowdsource the training data. They've actually annotated all of the 2016 presidential debates. That's their main training data set. And they split it into sentences, and then they classify each sentence as there's no factual claim, there's a factual claim, but it's not worth checking, it doesn't matter, or there is a claim that is worth checking. So they build a classifier to do this. This is how that classifier works. It's pretty straightforward. It is, it's basically bag of words plus some other information. So you can see what they do here, just sentiment, and there's your TF-IDF, right? I forced you to learn this the very first class, not because I hate you, but because everybody uses it. You also get some parts of speech and some entity stuff. You feed this all to a classifier. They tried a bunch of different classifiers. There's no magic. I think they found that what's it called? Oh, damn it. I forgot the name of this classifier. The vector distance, not SVD, support vector machine, SVM, worked best. But if you look at this paper, you can see where sort of about how well they do. So these are the three classes. NFS is non-fact sentence. NFS is unimportant factual sentence, right? So these are sentences that are factual, but they don't want to check. And CFS is checkworthy sentence. So it's a three-way classifier. And on their training data, they get what? Here we go. 70% precision, about the same recall. So you can build a classifier that takes sentences and tells you more or less whether they're worth checking. And this is sort of the middle part of this model, is do we care? Because then you have to throw a lot of processing power at the next step, which is, can we match this against previous fact checks?
When was this paper?
This paper was last year, I think. Yeah, KDD 17. Interestingly, and this will come up again, basically what they found is one of the strongest signals for whether it's a factual claim is, check this out, cardinal number. Checkworthy factual claims are more likely to contain numerical values, 40% of checkworthy factual sentences. So this thing here, PCD, means that this is from the part of speech tagger, and the part of speech tagger says it's a number. That's a very strong signal that it's a claim that should be fact-checked. So this first box we're not going to talk about because this is very standard technology. We're talking now about this checkworthiness filter. The third box is the claim matcher. So the idea here is to match it against previous fact checks. And ultimately, we hope, match it against other reliable sources of information. Even just, did they say something that contradicts the first sentence of the Wikipedia article on the topic, would be a really useful thing to build. Here's another conceptualization of automated fact-checking. This is from FullFact, which is a British fact-checking organization. They did a very nice report a couple years ago talking about the system they're building and the approach they're taking. And it's similar, right? It's monitor a bunch of sources, find the claims, and then check claims, and then they have this fourth one, which is to publish something about what they found. And as I pointed out, a lot of this stuff is ready now, right? So, for example, you don't even need to do text-to-speech. You can do closed caption information on TV stations. They also monitor the Hansard, which is the UK parliamentary record. The American equivalent is the congressional record. So you could just ingest that continuously and see if Congress is saying true things or not.
Just a
Yeah.
small question. When you say see if it's contradicting, how would you do that in terms of, like, would it be like a machine learning thing to see what has been said? Okay.
Yeah, that's the hard part, right? That's the sort of third box here in both of these diagrams, right? You can do some things now. So FullFact has a prototype automated fact checker. It doesn't seem to be deployed. I know about this from various articles where people have written it up. It's been presented at conferences. Unfortunately, I couldn't find any videos of those talks or anything. But this is the idea, is that, so here is tagged transcripts of political speech. So economists have said GDP is rising. So they're at the point where they can parse that and match it against, they have a structured database of official statistics and say, yep, it's true. From 2015 to 16, GDP rose. Now, even statements like GDP is rising are not as simple to fact check as they seem. For example, rising over what time period? We saw this during the presidential debates with claims that crime is increasing. It's like, well, yes, over some time periods in some places. I've shown you crime in context, right? The beautiful Marshall Project. Yeah. Right, so it depends. Even then, these statements are not obviously factual. Again, it's this translation from words to numbers, right? That's exactly what we're doing, our words to data. But it's useful, right? Here it's checking the hospital bed statement. Hospital beds were cut, true. And here it's got this sort of nearly true thing, right? It hasn't quite halved, but it is falling. So they've got this working, and it really only works for this type of numerical statement. They don't have this working for more complicated statements. But as we know from this, or not here, as we know from this research, claims worth checking are very often numeric. It looks like a little less than half of them are numeric. So checking numeric claims buys you quite a lot. For non-numeric claims, we need to start to go to the cutting edge of NLP research. And we're going to talk about a task called entailment, or checking entailment. The idea here is that you have two sentences called T and H. I think T for text and H for hypothesis. And the idea, does T entail H? So if I look at, where's an example of this? Here you go. He received the letter from the secretary as the text, and the secretary delivered the message to the employee as the hypothesis. If T is true, is H true? Another way to think about it is T the same claim, or almost the same claim. It's actually important that there's a little looseness there, because there can be information in one that isn't in the other. So a classic example of this is if you say, the company constructed the bridge, and you say the company was hired to construct the bridge. You want your entailment algorithm to say, yes, it entails that the company was hired to construct the bridge. But the information is not the same, because in the first sentence, you know that they completed it, and in the second sentence, you didn't. So entailment is not equivalence. It's sort of subset or near equivalence. And the idea is that entailment has become a unifying framework for many NLP tasks. So for example, you can use this for question answering. If I say, is Rome a city in Italy? You are looking for a statement in your source documents that entails the question. All right, so you can use it for information retrieval, and you can use it for fact checking in a couple different ways. You can use it to find fact checks. So you are looking for a fact check, the title of which is entailed by the claim. So if we go back to that Snopes article, right? If I have the claim, Obama used tear gas all the time, I know that this fact check is related if the claim entails the title of the fact check. And ultimately, back to your question, Shreya, we would like to check sources other than fact checks, right? It would be handy if we could just search search the web for a reliable source that supports or contradicts the claim that was just made, right? So that's the holy grail, the much more complicated cases. Right now, it's just being used to search against fact checks. So this is a very complicated thing to do, right? To check if one sentence entails another. because it's so complicated and interesting, I want to talk about some of the algorithms that have been used. There is a platform, like a big open source project called the Excitement Over Open Platform. And the ENT here, it's some acronym, but the ENT is short for Entailment. And it does a bunch of things, but entailment is pretty basic. Yeah, so this task is now known in the NLT literature as recognizing textual entailment. This platform actually tests for entailment, and it does it like this. It takes the claim pairs, right? So this T and H. It does all of this pre-processing, including like parts of speech tagging and sentence diagramming and so forth. And then it feeds it to a decision algorithm. Oh, that's interesting. There's no need for us to answer it. Don't answer it. Oh, okay, thank you. Okay. So it feeds it to a decision algorithm, which can have as input all kinds of other types of information. So, for example, it may need to know that if A buys B, then that means that someone sold B to A, right? These types of logical relationships are what it gets from all of these other sources. And we can play around with it. So here it is. Here is an online demo of what it does. Would anybody like to give me a text and a hypothesis to check entailment?
Just some sort of statement?
Yeah, so a claim and another claim. We're going to try to see if the first claim entails the second.
Oh.
I forgot my backpack.
Okay.
And I don't have my backpack.
Okay. Yes. Score 0.49. Okay. So there you go. It says that that entails, one entails the other with medium confidence. I can also, I think if I clear this, you can see sort of how it does on these training sets. You can see what this looks like, right? So there's a bunch of text entailment pairs. And you can see how well it does. So here, for example, there is no entailment, but it says yes. It says yes. So here's the problem. Until recently, it held the record for the nearest galaxy. So the hypothesis is actually false. The algorithm didn't see the until recently. Here's a case where, in fact, the negation is entailed, and so it got it wrong. So this is a pretty common problem for entailment algorithms. They're not very good at detecting negations, and we'll see why in a second when we start looking at how you build an entailment algorithm. It's surprisingly stupid, as most AI actually is. How many of you have studied entailment in your AI classes? Okay, so basically nobody. Okay. So there's a bunch of ways to do this. This is one way. It's called the transformation-based method. And the idea here is that you have a bunch of transformations which turn one sentence into another while maintaining the truth value, meaning that if the original sentence is true, the transformed sentence must be true. And so you need a big database of these transformations, right? This is what I was talking about. This is why you need to feed it Wikipedia or WordNet, is you need to be able to have these sort of very specific transformations, knowing that received and sent have a certain relationship. And so you try to turn he received the letter from the secretary into the secretary delivered the message to the employee one step at a time. Of course, this also depends on whether you know he's the employee, which is actually the first step here, co-reference substitution. So presumably from other sentences in the text, you know he's an employee. And the idea here is it's almost like a theorem prover. If you can find a transformation sequence that succeeds, then you have proved entailment. So there's a bunch of algorithms that do this. This thing, Beauty, is an algorithm that you can play around with, although I don't think they have an online demo. My sense is that transformation-based entailment is falling out of fashion. Oddly, what we have now is a lot of, one of the most common algorithms, including the algorithm I just showed you, is based on edit distance. So, edit distance. So you all know what edit distance is, right? Levenstein distance. You're seriously not going to believe that this algorithm is this dumb, but I'll show you the basic algorithm, and it goes like this. So let's go back to our example. What was it? I forgot my backpack at home this morning. I don't have my backpack. And what you're going to do is, it's kind of like the transformation example where you try to turn one into the other. But rather than getting clever about syntactic rules and sort of the logical structure of the sentence, we're going to do this at a purely lexical level. And we're going to try to turn one sentence into the other at the token level. So what we're going to do is we're going to say, well, let's delete these words. These ones already match. And let's turn forgot into don't have. That already matches. And there we go. And then the next thing we need is a cost function. We need to assign a cost to each of these transformations. So we can have some fixed cost. We're going to say, okay, we're going to assign a cost of 1 to every word that we have to delete. So this one is cost 4. And then if we do a substitution, one of the things we can, now here's where we start to get clever, right? Rather than just having a fixed cost for adding or deleting words, we can say if the words are related, the cost is lower. So if forgot and don't have are synonyms, then we can say they're cheap. So how could we tell if forgot and don't have mean the same thing? Or are related in some way? We've actually looked at a couple different methods in this class that we might be able to use here. Anybody got guesses?
Cosine distance between embeddings.
Yeah, okay. So we could do word embeddings. In this case, it's a little bit complicated because we need to do an embedding between a single word and a 2-word phrase. But yeah, we can use word embeddings and look at the vector distance. So cosine distance, for example. We need some sort of similarity metric, right? So we need what we are looking for, similarity between forgot, don't have, okay? And we could use word embeddings to do that. Another way we could do it is we could look up in a thesaurus, like in WordNet, right? It may be able to tell us that 2 words are synonyms, or they could be near synonyms, right? So for example, when we watched the IBM Watson video, it was talking about liquid and fluid. All right, now a liquid is a fluid, but a fluid is not a liquid, but liquid and fluid are closely related. So you get, if you're doing substitutions, you use similarity at the cost, right? And so, okay, let's say this has cost 1. So what you look for when you're doing entailment through edit distance is you look for what is the cheapest transformation from one sentence into the other, right? What's the cheapest set of edits that we can make? And you can get sort of arbitrarily complicated about this. You can throw in all kinds of other information. So for example, one common thing you use is IDF scores. If you have to add a word, you say that that word is, the cost of that word is the IDF score on that word. So adding a the is cheap. You probably don't have that because you have stop words, but adding a very common word is cheap because the word's very common, sure. Adding a very uncommon word is very expensive. All right, so here's TF-IDF. Again, you can come up with all of these sort of cost functions for deciding how, the idea of cost is that it should tell you how similar are the two sentences if you make that edit. Yeah.
Would adding a negation word be of high cost?
Right, so that's it.
I don't have my backpack versus I have my backpack.
So that's one of the things you can do. So a lot of these entailment algorithms, as we saw, have trouble with negation. And so one of the ways you can try to improve the performance with negation is by making the addition of a negation word very expensive. So perhaps this is an unrealistic example because adding a don't should be suspicious to the algorithm.
I guess then it would be like, if we have another sentence saying, I have my backpack, I haven't lost my backpack, it's at home.
I haven't lost my backpack, it's at home. Yeah, so we'd have trouble with that. Yeah. There are all kinds of algorithms that are based on edit distance. So I've been talking about just purely lexical, like replacing tokens in a sequence. There are tree-based edit distance algorithms where you can like replace a noun phrase, for example. There are lots and lots of variations of this edit distance approach. There's dozens of different similarity and cost functions. This is a big active field of research. The diagram that I've pulled up here, what this does is it sort of goes one step above that. So it does this pre-processing, so like tokenization and part-of-speech stuff. And then it uses this edit distance idea, this Levenstein distance is edit distance. It uses WordNet, which is basically a big dictionary and thesaurus, to try to understand how some of the, so it basically it takes the two sentences and then generates 3 sets of features. One of them is the minimum edit distance. Another one is how similar the words are in WordNet. Another one is the longest common substring. So substrings are very common in entailment problems, right? So check this out. Permanent lung damage. If you have a long common substring, that is a signal that one entails the other. Again, this stuff is really stupid, right? Like you sort of want it to be smarter than this, but it's not. So it takes all of this stuff and then it throws it into a support vector machine and tries to compute a yes or no. It actually has 2 here, right? So it has this 2-step. It discriminates entailment from non-entailment, and then it has another step where if it's non-entailment, is it actually entailing the contradiction? Anyway, this is the literature on this is pretty huge. I'm just showing you a couple examples of how you can do this. Here's a paper which is going to appear at the Computation plus Journalism Symposium in February. And using the excitement library, which we just played around with, they actually get pretty well. So the training data set is sentences from the 2016 primary and other debates. And then those are where the T's come from, and then the H's come from the fact checks that PolitiFact did. And using this open source library, they got actually 99% recall for non-entailment and 90% for entailment, which is super high. So they actually got pretty good here. Of course, they're not telling us the precision, right? So the entailment algorithm says yes a lot. It's not clear how often it says no, but for their goal here is just to find relevant fact checks. So actually the recall is the interesting question here, right? So it asks, you know, did this thing that the politician just said, does it match a fact check that I have in the PolitiFact database? That's what they're trying to do here. They're not trying to solve the more general problem of like, find me some internet reference, which tells me whether what they said is true. The most sophisticated method for checking entailment, or sort of the emerging method, is deep learning, which I'm just going to call it derp learning from now on. I want to make that one character search and replace.
What is it?
Nothing. Derp learning, yes. So this is from a paper from the OpenAI partnership, which again, they published some tools. And this paper shows how to do a variety of NLP processing tasks with the same type of network. And here's the idea. For entailment, what you do is you basically just glue the premise and the hypothesis, so the T and H pair together with a delimiter between them, and you feed the whole thing to a type of recurrent neural network. It's a recurrent neural network called a transformer. I'm not going to get super into the architecture of it, but I'll sort of sketch a schematic of how this works. The idea with this type of neural network is that it's pretty similar in concept to the word embedding network. You have a series of tokens. Okay. You transform each one through a first stage, which is an embedding. So rather than doing like one hot over the vocabulary or something like this, you go to, say, 500 dimensions. So you start with a word embedding, and the word embedding represents each token. That gives you some advantage immediately because it will do some synonym handling. You start each in embedding, and then you do this. I'm just going to call this a network. And then the network has to predict the next token. So it outputs the prediction of what the next token. So we hope it says forgot. It probably can't know it's forgot from I. But the recurrent part is it also has connections to the next level of the network. Which now has seen I forgot. And after you've seen I forgot, your prediction for my is probably pretty good. So the idea is that we feed some information, not necessarily prediction, some other information through each stage of the network. And at each stage, we try to predict the next token. And we train the network until the weights give us the highest accuracy we can get on this prediction task. Okay, so now we've built a network that is capable of guessing the next word in the sentence for a huge set of training sentences. So it's learned something about the structure of English. In practice, it turns out you get a lot better performance on this if you use attention mechanisms. In other words, you have a way to tell it, well, you know, look at this word 3 sentences back, or 3 tokens back. And there's this whole literature on attention mechanisms and so forth that we won't get into. But the idea is you build this predictor, and then when you want to do the entailment part, what you do is, rather than predicting what the next word is going to be, the only point of that task was to try to make this network understand the structure of English. Okay? And the idea is that if it can understand how to predict the next word, it must understand something about the structure of the sentence. So then you say, no, we don't care about that anymore. But what we are going to do is we're going to take all of this output, okay, and we're going to put another network there, another multi-layer convolutional style neural network. And now what it's looking at is it's going to look at the prediction of the next word over this whole sequence. And in this case, remember, this sequence is, we just glue the 2 sentences together. I forgot my backpack, some delimiter, and then the hypothesis sentence, right? We take this whole thing, we run it through the predictor, we take the outputs. Remember, each of these is 500 dimensional because we're in the word embedding space. We put a big convolutional network on that. We train this part, and then we have our final answer, right? Basically, we're trying to extract 1 bit of information. Is it entailed, yes or no? Or maybe a little more than 1 bit, but probably confidence, right? Yeah.
So the point of gluing them together is to also, and I'm not able to understand how that kind of leads to using that prediction for saying how this entails that. Or like, it uses those values and then compares them to the values this sentence would give.
So the point of this is that you can get better performance. So you could just build 1 big network and try to train it on entailment directly. It doesn't work very well. And one of the reasons it doesn't work very well is because you need a huge amount of training data to get a good understanding of language. So instead, you give it an unsupervised task, which is just the next token prediction problem. And for that, I mean, you have much training data as you have English text. So you can train it on 100 million examples. We've got lots of text. And the point of that is to try to train it to understand the structure of English text. Then once you've trained it to understand the structure of English text, right, you've trained this part, then you just train this part. What you assume is that the predictive output, really what it is it's some information about the semantics of the sentence. And so you feed all of that to another network, which looks at all of that at the same time. And that, you can think of this as basically just a classifier. So if you like, what it is you build 1 network using unsupervised learning to generate features, and then you put another network which takes those features and builds a classifier on top of it, which tells you the entailment result. And so this is what state-of-the-art systems look like, not just for entailment, but for many problems. This idea of building 1 network. In the literature, this is called a transformer network, or the one version of this, a popular version of this that OpenAI uses is called a transformer network. Right? And so you can actually solve many different types of NLP problems. So for entailment, you throw a sequence which is just the premise and the hypothesis at it. And this transformer to linear thing, transformer is this big prediction network we've been talking about. Linear is this deep neural network on top of it. And you can do a great many things, right? You can just do text classification, you can do entailment, you can ask how similar they are, you can do like, try to do like reading comprehension, answer a multiple choice question, all with a very similar architecture. And the idea here is that you are building it this way so that you can use a very small amount of labeled training data, because the entailment corpuses are not that large, right? We might have 10,000, 20,000 examples. But if you start by training it in unsupervised data, you have way more data for it to learn English. So this is the state of the art. none of these automated fact-checking systems are in production yet. I would guess we're going to see one in the next 3 years, that we're going to have the video playing on CNN with automated fact checks pop up. I think the first thing we're going to see is a human-in-the-loop version, where there's that the system runs and an editor watches the fact check it picks and says yes or no.
Actually, did you see that CNN just started doing this for Huckabee Sanders' press conferences?
So there's manual real-time fact checking now. Yeah.
Right. And I thought that was
What do they do?
They're manual. It's fully manual, but they're doing fact checking of
Everything that
the
she
press
said?
conferences ever since the Acosta got there.
Yep. Anyway, so I find this very exciting. I think this is a really interesting application of AI. Yeah.
Are we,
I thought that was a question.
it is a question. We're switching topics, but I don't want to.
We are about to switch topics, yeah.
Okay. I'm curious if there's any work being done around deepfakes, because that's terrifying to me. Fake videos. Is anyone getting ahead of, do you know if anyone's getting ahead of that problem before it causes real damage?
Oh man, yeah. So there's a whole topic that I haven't talked about at all in this lecture. Yeah, so there are people thinking about deepfakes. Machine detection of deepfakes, there's some of it that's happening. So this falls under the general category here is adversarial AI. So you probably, have you seen the research showing that you can make a convolutional neural net, like fool it into spitting out a particular answer? The like toaster? Okay, this is fun. So convolutional neural networks are not very smart. And no, I want the original paper. Oh yeah, so here's the fun thing. So what you can do, and this is from a paper last year, is if you just show this classifier a picture of a banana, it goes banana. But if you reverse engineer the network in the right way, basically you take you sort of run it backwards, right? You take the output for toaster and you look at what pixels feed into that input. You can make something which is like the Uber toaster, right? So this image is more toastery than any toaster in reality, right? This is what the network thinks a toaster is. If you print this on a sticker and put the sticker on the table next to the banana, the network says it's a toaster.
Facial recognition, throw it off.
Yeah, right.
People are putting it on like signs to mess up self-driving cars.
Right.
That's fascinating.
Right. This is really funny until you start thinking about self-driving cars.
Yeah. Whoa.
So I actually know someone who's employed by a self-driving car company whose job it is to solve this problem. And the approach that she and the research community are taking is you basically use adversarial networks. So anybody know what a generative adversarial network is? All right, you wanna break it down for us?
Yeah, so you have a discriminator and a generator,
Mm-hmm.
and the generator's role is to create samples that look real,
Mm-hmm.
and the discriminator's role is to determine whether they're real or fake.
Mm-hmm.
And then, based on that, they sort of trade each other and improve each other's performance.
Right. So this was originally developed to try to build better image classifiers, because the idea here is that one of these networks tries to fool the other one. But you can use this to try to build networks that are more secure, right? So what you do is, in this case, we'll call this tries to fool the discriminator, tries to spot the fake. So the idea here is you have a synthesized image, and then up here you have a real image of a banana, for example, or a politician. And what you do is, this is the thing you're trying to build. You're trying to build your image classifier. Right? You're trying to build an image classifier that can't be fooled by a fake image. And so you train both the generator and the discriminator at the same time. You train up one and then you test the discriminator on it. It produces training data for the discriminator. Then you train the other one until it can reliably figure it out. And then, I forget exactly how this loop works, but then the generator learns from how the discriminator figured it out. So basically you put two machine learning models in an arms race with each other, and you get much better results. So this is the sort of technical approach to trying to build robust image recognition systems. My sense is that the technical approach is not going to be sufficient. All of the institutional apparatus that we are building up for fact-checking and investigation of false news generally, I feel that that is ultimately our line of defense. I think that we are going to be able to deal with deep fakes, not because we have very clever algorithms for identifying faked images, but because we have news organizations and fact checkers looking at a piece of video and doing all of the things they do with any piece of video, right? When you, I mean, we've already been down this hole, right?
Isn't that one of the problems you said with the current classification of news articles on Facebook, that it took too long?
Yeah.
And by the time they actually classified it, already propagated as far as it would go.
Yeah, so, right. So that's a problem. I mean, and that's why machine assistance is going to be important here.
Yeah.
Right. I think what we're going to see, and in fact, I bet what Facebook already does is a triage. They throw classifiers at it and say, "Oh, definitely fake. We don't need to pass anything from InfoWars to the fact checkers, right? Or definitely true. It just scores very low. It's from reliable sources, and then everything in the middle you have to pass to the humans to check." But I mean, the problem of identifying a deep fake is not any different from the problem of trying to figure out if a video posted on YouTube is really a video of a natural disaster or really a video of an attack in Syria. Right? News organizations already do this. We had to invent this stuff in the last 10 years to deal with social media coverage, especially Syria. One of the reasons that Syria drove this problem was because there weren't any reporters there for a long time. So we already know how to do this, right? And we already know how to take a video that looks completely reasonable and figure out that it's not what it seems to be. Okay. Yeah, that's my take on it. I don't think the technical methods are really going to be the solution. I think when computer scientists freak out about this, it's because they don't understand how fact-checking actually works. And a huge amount of fact-checking is context, not content. Right? We look at the things around the artifact. And algorithmic methods can't do that, by and large.
Yeah. But I guess I'm worried about like subtle changes in videos too.
Yeah, no, I mean...
Along the lines of like using court, right? Where any subtle thing in a video can determine whether or not you're guilty of a crime, right? And how do you make that, without having seen the video or having relevant videos to compare.
But we already have a mechanism for that problem.
What's that?
Chain of custody.
What's that?
Chain of custody.
Well, right.
Right, so we already have a mechanism that testifies to the authenticity of a piece of evidence. And if we don't have a chain of custody on a video file, it can't be used as evidence. Right. So, I mean, I don't mean to dismiss this as not a real problem. I think deepfakes are a real problem. I'm just saying that starting with how can a classifier recognize a deepfake is the wrong approach. And especially because I'm not sure that it's possible. I think generative methods and adversarial methods in machine learning are, by definition, going to generate fakes that cannot be detected by a computer. Right? That's the whole point of that's the problem that the networks are trained to optimize. Okay. The last topic for today is I want to talk about information diffusion. I'm going to talk about very general information diffusion, and then I want to show some results from a remarkable study of true and false information diffusion done on the entire Twitter corpus. So they looked at every tweet ever. There are a few large-scale information diffusion studies. So this is NIFTY, which stands for what? Oh, they're not telling us. It's some acronym. Anyway, what it is it scrapes a whole bunch of news and then watches stories go through it. So they stopped running this in 2015. But I wonder what this was. So for each of, what it does is it extracts quotes. So the reason it looks for quotes is because quotes are relatively conserved when they're reproduced. You would think that quotes are conserved verbatim, but that's actually not the case. They actually mutate. First of all, they get shorter and longer as people quote more or less, but they actually start to get, there's errors and paraphrases as well. And for each quote, oh, there's only one variant here. Let me find another one. What's the difference? Yeah, okay. Let's find a more interesting one. Oh, come on. Variants. Here we go. Here's one with 5 variants. So you can see that it figures out that these are the same thing. And then for each of them, for all of them together, it sort of graphs the prevalence. And then you can see the actual source, or maybe not in this case. Many of these are pretty old at this point, but we could probably pull them up with archive.org. There we go.
What are they linking to?
The original source,
Oh, okay.
except in this case, I don't think it is the original. Oh, yeah, so this is a case where it misfound it, right? No doubt in my mind, I have no doubt in my mind, it's actually not the same. There's no mental illness in there. Okay. Well, anyway, that's the idea. So it tracks information diffusion across hundreds of news sources. Wow. And it's really falling apart. One of the things that you can see is what I call an attention curve. This is very characteristic of basically any information diffusion. So if you're looking on social media, if you're looking at news coverage, if you're looking at almost any measure of mentions or information flow, what you're going to see is a slow buildup and then a peak and then a sort of exponential fall off, right? A long, slow decay. I don't know that there's a standard name for this phenomenon, but I've been calling them attention curves. So we can do this. We can track information flowing. Obviously, social media is one of the sort of obvious places, but we don't even need to look on social media to do this. We can do this just with web content and watch these phrases spread and mutate. The first version of this was actually called Meme Tracker, and they did it in 2009 when the blogosphere was still a going concern. And one of the very interesting results from that, and this is something many people had really wondered at the time, is new information generally picked up by professional journalists or by bloggers first? And in their study, they actually found that media got it first by a couple hours. So you can actually answer questions like this if you do the right types of analyses. And again, you see these attention curves, right? A slow build up, a peak, and then a slow decline. And the decline tends to be a longer tail or wider than the build up. Looking at social media, what you see are cascades. So this was a visualization of the original tweet that said bin Laden was killed. It was by a guy called Keith Urban who worked in the White House, and he tweeted, he was the first person to say that Obama's special announcement was going to be that they had killed bin Laden. And he tweeted it. You can see sort of the constellation of retweets around that. So each dot is a person, each edge is a retweet. And then via some people, some intermediaries here, it got to Brian Stelter, who was, I think he was CNN by then, who tweeted it, who created his own explosion. So you can sort of see with maps like this information flow with a series of hubs. There's a fundamental concept here that is a cascade. There's a single tweet somewhere that eventually generates a series of retweets. Now the same information can have multiple cascades, right? So that same information could have appeared in multiple places. So eventually someone else, official, must have tweeted something and that produced its own cascade. This is another one of those cascades. This is Coney 2012, which was this video about, oh gosh, what is that group called? It's a group that operates in Uganda and neighboring countries, led by Joseph Kony. I can't remember what this group is called. Anyway, not good people. And this was a documentary that they made, which at the time was it got to 100 million views faster than anything ever. And this is part of the retweet network. Jason Russell is the director. Invisible Children was the name of the group. And these clusters are actually high school classes in the Midwest, because how this group operated is they went and toured schools giving talks. And so when they released this video, it spread through these clusters of pre-existing networks. So you can see a lot of interesting stuff here in terms of network structure. Fast forward to, oh, this is a really interesting one as well if we're talking about information flow. This is a little bit of a digression for us today, but one of the best articles on content performance that I've ever seen. Brian Abelson did this while he was a Tau Fellow. And he was working with the New York Times, and he was looking at, he built a very simple model to predict how many page views an article would get based on whether it was tweeted by the New York Times, whether it appeared on the front page of the New York Times at any point, whether it was wire stories or original content. And one of the really interesting results from this was that original content does better than wire stories, which shouldn't be a shock to anyone, but it's nice to see that it's confirmed. And you can see that by the difference between the orange and the blue here, right? So here's the wire content. They still run a lot of AP stories and stuff for breaking news. And then here's the original content. And these are ones that did not appear on the front page and were not added or were not tweeted. One of the reasons I like that fact is because, when I talk to people about news and news trust, one of the things that I hear is, I wish people would just give me the facts, right? I just want objective reporting. I don't want opinion. All of the data we have suggests otherwise. You can get straight reporting. You can read the wire services, but people don't want to read the wire services. They want to read stories that contextualize the fact and tell you what it means. And there's other ways of getting at that data point. But by and large, when someone tells you they just want the facts, I think it's one of these aspirational things. It's like people's wish lists on Amazon, right? These are the books that I would have liked to have read. That's the type of news that I wish I was reading or something, because that's not what people actually share and respond to.
Or they use it as a weapon to be like, oh, you're always covering the things that you want to cover with you don't give us what's happening and you don't keep it accountable.
Yeah, it's all still available. I mean, it's sort of one way to think about it is there's a sort of a hierarchy of reporting, and the wire services are at the bottom with just the facts, much less contextualization. And then other reporting builds on top of that, all the way up to pure opinion, which is purely contextualization and no facts, or no new facts. There have been scattered studies before trying to figure out the relative popularity of false information versus true information. Here was one that happened that Craig Silverman did in BuzzFeed a couple of years ago. And of course, the headline here was, the top 20 fake news stories had more engagement on Facebook, so this was done with Facebook data, than the top 20 real news stories. But this is just, 40 stories on one platform over 3 months. We finally have a much better source of data on this problem, which is every tweet ever. So this is a paper called The Spread of True and False News Online. It came out of a team at MIT. It appeared in Science earlier this year, I think March. And what they did was they took the entire Twitter data set from 2009 onwards to 2018 or something, and they identified every cascade. Well, actually, that's really every tweet. So they constructed the entire retweet structure. And it's a cascade of size 1 if it's just one thing that was never retweeted. But of course, cascades can be much bigger. And then they took a database of every fact check from 6 organizations, so PolitiFact and Snopes and so forth, and they looked for places where a link to that fact check was mentioned in the cascade somewhere. These are reply cascades, not retweet cascades. Or it's both. And so the idea is this. There's an original tweet somewhere, which then has a bunch of retweets and replies. And somewhere in here, in fact, they restricted it to be just the first reply to make sure that these two things are talking about the same thing. Somewhere in here, there's a fact check URL, okay? And so then this whole thing becomes one cascade. There's various parameters of the cascade, such as the depth and the maximum breadth and the total number of nodes involved, which we'll see in a minute. But they were able to identify about 500,000 cascades, which included a follow-up link to a fact check. And then they used the fact check to label the entire cascade as, oh, that marker doesn't work, as true or false, right? Based on whether the fact check was true or false. So now they have 500,000 cascades that they know are true or false. And just for good measure, they hired some people to independently fact check another 13,000 cascades so they can do robustness checks to see if there's selection bias in the fact checking organizations. And here's the results. So what we are looking at here is a CCDF, a complement cumulative distribution function. In other words, and they call a rumor. The rumor is just somebody says something. It's just a cascade. what we're looking at is how many of these cascades, how many of these structures of conversations on Twitter do we have for each rumor? And of course, 100% of them have at least one, or they wouldn't be in the data set. But only, 1% of them have 100 or more cascades. So we're just looking at sort of how many of these conversations happened around each of these items of news. And you get more conversation around the false ones. Or you can look at just the data when they also did topic categorization, just the data when you're talking about politics. And there it's even worse. The conversations around true statements fared significantly worse. We had significantly fewer conversations than around the fake statements. And they analyze this a lot of different ways. So you can look at various metrics on the cascades. Again, we're looking at complementary cumulative distribution functions. So, only 1% of cascades went to depth 10, is what this is saying here. But the false cascades were deeper. They involved more people. They had a higher maximum breadth. So the breadth is at one step of the conversation, what are the maximum number of people who retweeted or replied? I can't remember what virality is. It's some sort of metric of the number of people involved. They spread faster. You can see this is a higher number of minutes to reach the same depth. They involved more users. They had higher breadth. Basically, in every measure of information diffusion, the statements which were decreed as false by the fact checkers did better. And most of the cascades were in politics, and I guess urban legends is a close second, which shouldn't be a shock. Okay, so false information spreads faster and wider on Twitter. Why? I have one hypothesis about what the reason for this is, which I'm pretty happy with, but I'm wondering what all of you think.
Eye-catching and more dramatic than the truth.
It's more dramatic than truth, yeah. Okay, other ideas here.
What does spread mean exactly? Is it the spread of an article? Is it a conversation around a topic?
There doesn't need to be an article, so there needs to be a fact check link somewhere in the cascade, but they define news as just somebody says something on Twitter, that's it. They're not concerned about whether it's an article or what.
But how do they define relevant conversation around that topic?
Cascade,
Cascade?
yeah, of replies and retweets.
Replies and retweets, because I'd imagine fake claims would cause more conversation and dispute as well as agreement, right? So that could be a reason for the chatter.
Mm-hmm.
So just more expected. So like there's more entropy, like in the people want to be. There's more information, even though it's fake information in a way.
Mm-hmm. So in fact, they did a bunch of research on how true and false information differ. These are the graphs I was just showing you. And they found differences in emotion, so more disgust and surprise, and differences in information content. These are all measures of novelty. There are various sort of basically word distribution metrics of how much new information there is. And they found that false information was generally more novel and had more surprise or disgust. Yeah.
I have one question and then something else to say. The question is, they didn't look at the nature of the reaction that people had on Twitter, did they? Like, what were they talking about after engaging with this false content?
No.
And I would hypothesize that false content calls for people to chime in with what they think, whereas already, like, oh, okay, cool, this happened, this exists, it's true. What do I have to add? Nothing.
Interesting. So more potential for engagement. Yeah.
In a way, you can kind of think of trying to get information diffused if you're like a news source and or like you're just someone who wants to like get a lot of attention, it's like you can think of it as like a constrained optimization problem.
Mm-hmm.
And so when you eliminate the constraints, you can get like a much better result.
Yeah, so I think we're all talking about very similar things, and I think one way to think about this, and the way I think about it, is entertainment will always be more popular than news. Okay? And when you don't have to say things that are true, you're free to produce whatever is most entertaining, whatever has whatever reaction you want. And if the reaction you want is getting people to click on your site and buy a mattress, then, as you say, if you release the constraint of being true, there's a lot wider space. I really like, I'm going to leave you with a quote from Jay Rosen. He was originally talking about sort of what type of news to produce and what's most profitable to produce. He said, the challenge is not to stay in business. The challenge is to stay in journalism. So we definitely see empirically that if you are not constrained by the truth, it's easier to get wider distribution. However, that shouldn't surprise us, because if what you want is wide distribution, you shouldn't be producing fiction anyway. All right, thanks everyone.